Are you involved in First Tech Challenge? If you're a student in FTC and would like to learn CAD, OnShape is a great tool. It's browser-based, so you can get started in just a few minutes. I'll show you how to make this REV Basic Bot, and we'll teach you some OnShape basics in just over 30 minutes. I'm Lana Gerstenberger from Team 12827, and let's get started. Go to onshape.com/signup and select Request Your Education Account. Once you're on this page, select For Students. Fill in all of your personal information and select Create EDU Account. Create a document and name it Basic Bot. At the bottom of your screen, there will be two tabs, one named Part Studio 1 and the other named Assembly 1. The Part Studio is used for sketches and is perfect for creating your own custom 3D parts. In this video, however, we will be working in the Assembly 1 tab, so select that. On the left side of your screen, you can also see these two tabs. You can adjust between these two tabs as needed. Next, rename the assembly drive wheel. We need to insert some parts. Take a look at your toolbar. We will mostly be using these tools in the video. On the left, there are the undo and redo buttons, the insert button, and many other tools. As we continue, I will define the tools that we are using. Many of them are pretty complicated, so I will only be using the simple ones here. Click the Insert button, and in Other Documents, click Public. In the search bar, type REV Shaft Stuff Library. It takes a while to load, but once it finishes, select the library and select REV 42 1324 3mm spacer. It should be the first option on your screen if you search 1324. After you select the part, move your cursor in the empty space and left click. This way you can place the parts without them being right on top of each other. Next, select the 1326 through-bore bearing and the 1327 shaft collar and the 5mm by 75mm hex shaft. Go back to the previous page and search REV Wheel Library. Again, select the library that pops up and switch to the Assemblies tab. Select the 1354 90mm traction wheel and position it wherever you want. Go back and search REV Bracket Library. In this library, switch over to the Assemblies tab and select the pre-loaded bracket. Place two of these in your assembly. After you're finished, click the green check mark. In the top right corner, you will see a cube with top, front, right, and back written on it. This is an easy way to change your view of your assembly. You can also look around by right-clicking and dragging if you have a mouse, or double-clicking and dragging if you have a trackpad. Select one of the preloaded brackets. A complicated structure will appear with 3 lines going in different directions. This tool is how you easily rotate or slide a part. Select the center circle and move it around on your bracket until it seems to click to something. This might take a while as it is difficult to find the sweet spot, but once you have it, right-click and select Move to Origin, and then right-click again and select Fix to fix it in place. The reason for doing this is to have something that won't move as we create a lot of mates between the parts. It will also keep our assembly oriented in the right way so that we can use our cube effectively. In your toolbar, select the Fastened Mate. If you can't find it, there is a Search Tools button on the toolbar in the middle. A fastened mate will connect two parts using a face, edge, or a point. There will be no degrees of freedom in a fastened mate. Zoom in or out to find the best viewpoint and select the edge of the center circle of the bracket. Select the other bracket and the same edge but on the other side. the two brackets will snap together. Don't get scared if they look odd. We can flip the primary axis and rotate them to make them look normal. Offset this mate on the z-axis -15 millimeters. If you can't tell already, we will be using a lot of fastened mates. Create another mate between the edge of the collar and the end face of the axle. If needed, zoom in to get a better angle. Once they are mated, offset on the z-axis -2 millimeters. Create another one and select the edge of the center hole of the wheel. Pan around to reach the other side of the collar and select the face of it. Zoom in to make sure that the axle is aligned within the wheel. Shift your viewpoint to ensure that nothing is overlapping. Create another fastened mate between the face of the through bore bearing and the edge of the center hole of the wheel. If the mate looks weird when it snaps together, flip the primary axis and rotate the through bore bearing if the axle isn't lining up correctly. Next, select the edge of the spacer and the face of the through bore bearing. Flip the primary axis as needed and rotate it so the axle and the spacer align. Duplicate the collar by selecting it and using Ctrl-C and Ctrl-V. Create a mate between the face of the collar and the face of the through bore bearing. Again, flip and rotate as needed. Next, duplicate the spacer and create a mate between the duplicated spacer and the face of the collar. Change your viewpoint if you can't tell if it's aligned correctly on the axle, and then finish the mate. Duplicate the spacer again, and create a mate between the face of it and the spacer already on the axle. Next, create a revolute mate. A revolute mate links two parts together with a degree of freedom of rotation around one axis. You can find it on the toolbar right next to the fastened mate. Create this revolute mate between the edge of the through bore bearing shown and the edge of the center hole of the bracket. Look around your assembly and make sure everything looks right. Nothing is overlapping and everything is aligned correctly on the axle. After looking at different viewpoints, we're going to create a new assembly. Create a new assembly and rename it OmniWheel. Insert from the REV Shaft Stuff library the 1323 15mm spacer, the 1326 through-bore bearing, the 1327 shaft collar, the 1347 5mm by 75mm hex shaft, and the 1324 3mm spacer. Make sure to separate all your parts so they're not all on top of each other. Make a fastened mate between the collar and the axle and offset it -2mm. Insert from the REV wheel library, from the Assemblies tab, the 90mm Omni wheel. Make a fastened mate between the edge of the center of the Omni wheel and the collar on the axle. Make sure nothing is overlapping. Create another mate between the other side of the Omni wheel and the 3mm spacer. Flip and rotate as needed so everything is aligned. Select the spacer on the axle and the face of the through-bore bearing. Select the face of the 5mm spacer and the end face of the through-bore bearing. Flip and rotate if needed. Once everything is mated together on the axle, duplicate the through-bore bearing. Create a mate between the face of the through-bore bearing and the face of the 5mm spacer. Check to make sure everything looks aligned on the axle. Duplicate the collar and create a mate between the collar and the through-bore bearing at the end of the axle. Insert from the REV bracket library. In the Assemblies tab, select the preloaded motion bracket. Insert 2 of these and find the center of the bracket by dragging around. Once you have found it, move it to the origin and fix it in place. Mate the bracket to the other bracket and offset it on the Z-axis -15mm. After it is properly oriented, finish the mate and create a revolute mate between the through-bore bearing and the bracket. check to make sure that your assembly looks the same as this one. Create a new assembly and rename it Support Bar. Insert, and in Other Documents, go to Public and search for REV Structure Library. Insert the 1431 15mm extrusion, and then go to REV Bracket Library, and in the Assemblies tab, insert 2 of the preloaded inside corner brackets. Create a fastened mate and select the inside edge of the extrusion and the bottom screw hole edge of the bracket. Flip and rotate it until it looks like this, and then offset it on the Z-axis -5.5mm and on the Y-axis 20mm. Select the center hole at the end of the extrusion and wait until it clicks. Then move it to the origin. Rotate the extrusion 90 degrees and shift it -112.5mm. Fix it in this position. Create a fastened mate between the bottom face of the bracket and the inside edge of the extrusion. Rotate and shift until it looks like this, and then offset on the Z-axis -5.5mm and on the X-axis 20mm. Finish the mate. Make sure your support bar assembly looks like this, and then create a new assembly and rename it Basic Bot. This will be the final assembly. Insert from your assemblies the support bar. Fix it in place when it's centered. Next, insert another support bar. Create a fastened mate between the inside face of both extrusions on both support bars. When they snap together, they will be right on top of each other, so flip the primary axis and that should fix it. Next, offset them on the Z-axis -121mm. Insert from the REV Structure Library the 1432 15mm extrusion twice. Create a fastened mate between the face of the two long extrusions. Offset this mate by negative 225 millimeters on the z-axis. They should look like this. Next, create a planar mate. A planar mate allows all 6 degrees of freedom between two parts. Select the face of the left support bar and the left long extrusion. It should look a little bit weird at first, but create another planar mate between the face shown on the long extrusion and the end center circle of the support bar. It should look like this now. Crazy, right? Look at it from above to make sure it looks the same on your assembly. Create another planar mate between the edge of the lower support bar and the left end center hole of the long extrusion. Offset this mate on the z-axis negative 40 millimeters. Now your assembly should look like this. Make sure yours looks the same before moving on. Next, insert from the current document in the Assemblies tab, insert the drive wheel. Rotate the drive wheel assembly 180 degrees in one direction. And 90 degrees in the other. Create a fastened mate between the screw hole on the drive wheel assembly and the inside edge of the extrusion. Zoom in if you need to get a better angle. It will look weird at first, but offset it negative 5.5 millimeters on the z-axis and 7.5 on the x-axis. Looking a little bit better now, right? Insert from the REV Motor Servo library and search the 1300 core hex motor. Rotate the motor 180 degrees and create a mate between the screw hole shown and the specific bracket hole shown as well. Flip and rotate as shown and offset it on the z-axis negative 75 millimeters. Create a slider mate. A slider mate is similar to a revolute mate as it only has 1 degree of freedom to allow a part to slide. Create the mate between the end face of the axle and the center face of the motor. Rotate so the axle aligns with the motor and rotate about Z 20 degrees. Next, insert from the REV structure library the 1359 screw. Create a fastened mate between the bottom face of the screw and the screw hole shown on the bracket. Next, we'll be using a tool called Replicate. Replicate allows you to replicate a certain part and its mate onto individual edges, points, or faces identical to the original part. The replicate part can be searched for if you can't find it. Once you do find it, replicate the screw onto 2 other screw holes on the bracket. Make sure you select Match Individual Edges so that you are able to replicate it on the edge, not the face or the part. Edit the fastened 4 mate and change the offset distance to 0. This will move the motor back close to the bracket. Insert from the Current Documents in the Assemblies tab another drive wheel. Rotate the assembly 180 degrees. Create a mate between the screw hole on the brackets shown and the inside face of the extrusion. Rotate and flip until it looks like this. Offset it -5.5 millimeters on the z-axis and 7.5 millimeters on the x-axis. Duplicate the 1359 screw and create a fastened mate to connect the screw to the bracket. Use the Replicate tool to replicate the screw into the other 2 screw holes as we did before. Select the screw, then select Match on individual edges, and then select the other 2 screw holes. Duplicate the 1300 core hex motor. Create a mate between the screw hole shown on the motor in the top screw on the bracket. Flip and rotate as shown, and then offset on the z-axis -75 millimeters. Create a slider mate between the end of the axle and the center hole of the motor. Rotate about z -10 degrees. Edit fastened mate 8 and change the offset distance to 0. If you drag the center of the motor, your wheel should rotate. Cool, right? Next, insert from this current document in the Assemblies tab, insert the Omni Wheel assembly. Insert 2 of these. Rotate one of the Omni Wheel assemblies 180 degrees in one direction and 90 degrees in the other. Create a fastened mate between the top edge of the screw hole shown and the inside face of the extrusion. The inside edge of the extrusion can be hard to get to, so pan around so you can view it easily. Offset it -5.5 millimeters on the z-axis and -35 millimeters on the x-axis. Rotate the other assembly as you did the last, 180 degrees in one direction and 90 in the other. Create a mate like you did before between the top edge of the screw hole on the bracket and the inside corner of the extrusion. Again, don't be afraid to pause the video to get to this inside corner if it takes a while. Flip and rotate as needed, and then offset it on the z-axis -5.5 millimeters and -35 millimeters on the x-axis. And you are finished with your Basic Bot assembly. Take a look at your final assembly. Because of the revolute mates, the wheels should move. Great job, and I'll see you next time.